Okay, let's try this again. So 4.4, linear inequalities, two variables, is the last lesson for Unit 4 and the last lesson before break. So I've already done this, but the audio didn't work, so we're going to redo it. These first couple ones are just warm-ups, all right? So if I was going to solve this, just remember, like, I would try to get the x by itself, so I'm going to subtract 5. Negative 3 is less than 4/3 x. I'm going to divide by 4/3. When I divide by 4/3, that means I'm going to multiply by 3/4, so I get negative 9/4 is less than x, aka x is greater than negative 9/4. So I was going to graph it, negative 9/4, open circle, shade to the right. Next one, I would subtract 4. I have negative 2x plus 4 is greater than or equal to negative 16. Subtract 4 to get negative 20. Divide by negative 2. Don't forget, when you divide by a negative, it flips your inequality sign. So I have x is less than or equal to 10. Close circle because it's less than or equal to, and I would shade to the left. All right, so with that being said, we're going to graph inequalities and eventually get into systems of inequalities. So when you're graphing a system of inequalities, you're going to have shading. All right, so I wrote down 3 steps that I think are very important. The first step is to write your equation in y equals mx plus b form. So if both equations have an x and a y, then you're going to write it into y equals mx plus b form so you can graph it, and that's what we're used to. The other thing too is solid or dashed lines. So if it's less than or greater than, you know how it's an open circle? That means a dashed line whenever you graph it. If it is less than or equal to, greater than or equal to, that's a solid line, just like a solid closed circle. So this first one, what I tried to show is if I rewrite it 3y less than negative 2x plus 3, I would divide by 3 on everything, and you would get negative 2/3 x plus 1. So I'm going to start at positive 1 and go down 2, right 3, down 2, right 3, or I can go up 2, left 3. This is a dashed line. All right, now, on the shading, you can use test or intuition. So when I say test, normally I test 0, 0. So if you notice, 0, 0 is below the line right here. So if I plug in 0 for y and 0 for x, we'll see if it's a true statement. So 0 less than 1 is what I get. That is a true statement. So that means I would want to shade where that point is, which is below the line. So I'm going to shade below the line. So I would shade everything below the line. And if you think about it, less than normally leads less than, like below. So I'm going to go below the line and shade. If I have greater than, I'm going to shade above the line. All right, so next one, if I rewrite it, I need to add 8x. 8y is greater than or equal to 8x minus 32. Divide by 8 on everything. Y is greater than or equal to x minus 4. So I'm going to go down to negative 4. 1, 2, 3, 4. I'm going to go up 1, right 1. Plot the rest of my points. This is going to be a solid line. Again, I could use a test point. If I do that, I get 0 greater than or equal to negative 4. 0, 0 is right here. Greater than, though, I always think intuition. I'm going to shade above the line, so I shaded above it. And that's where that test point was, and it was true, so it works. So now we're going to take that, and we're just going to graph 2 at once, instead of just one individually on its own graph. So it's called a system. In a system, okay, you have either a union or an intersection. A union is an or statement, and intersection is an and statement. And you need to know that because on the Hawks, it's going to ask you, hey, do I want union or intersection? Well, if it says or, you're going to select union. If it says intersection, you're going to select, or if it says and, you're going to select intersection. All right, so, and rather than work all these out again, I'm going to show you what I did. I subtracted the 2x, and I got negative 2x plus 5, and I got y is less than or equal to that. So I went ahead and graphed it. It's a solid line because it's less than or equal to. And you could do a test point. I use intuition. Less than means I'm going to shade below the line. So that's what I did in the black. Now in the green, if you look at your equation, I need to divide everything by 4. Well, that's 2 over 4, which is the same as saying 1 over 2. So I went ahead and simplified my fraction for my slope. And I get negative 6 as my y-intercept. So I graph that. That's the green line. It's dashed. And I shaded below because it's less than. Or you can use the test point. Notice this is an and statement. So on Hawks, I'm going to select intersection. And that's all I did for that problem. It's the same way for B. Okay. So x plus y is greater than or equal to negative 3. I need to subtract the x. So I have y greater than or equal to negative x minus 3, which means my slope is negative 1 over 1. So I went down to negative 3 and then to do my slope. It's a solid line. And on the next one, I have 2x plus 2y is less than or equal to 6. I subtracted my 2x and I divided by 2. Again, my slope is negative 1, but this time I started at a positive 3. So now I would shade below on the purple line, above on the blue line, and it says it's an or, so on the Hawks I would just select union. A union means I would use anything that satisfies at least one of the inequalities. So on this one it's going to end up being the whole graph, but it just kind of depends on the problem. We're going to skip C, and we're going to do absolute value ones. So absolute value, don't forget, greater than or equal to is an or statement. Less than or equal to is a and statement. So this first one's an or statement. Now when you do absolute value, you have to get the absolute value by itself and then write your two equations. So this one I added 2 to get 17, and then I rewrote it as 4x minus 1 is greater than 17 or 4x minus 1 is less than negative 17. So that's my two equations. And then from there I solved them. Now I will tell you this is a little hint. Absolute value is almost always going to be a vertical line. And this one, if it's an or statement, think about it, union or, normally we shade out. So this is what it looks like. It's two vertical lines and I shade it out. One vertical line's on negative 4 and one's on 4.5, aka 9 over 2. On Hawks, you're going to get fractions, that's fine. Probably did it correctly, okay? The next one is an example of an intersection. So again, I got the absolute value by itself. I wrote two equations. When you write the second equation, you flip the inequality sign and change it to a negative. And that's what I did here. And then I divided by 5 on both sides, and I got my two answers. Intersection's an and, so I'm probably going to shade in the middle. And that's what I did here. I shaded in the middle of my two vertical lines. At any point, if you guys need to pause this video to look at something to see the work, go ahead and do that. Your homework is 2.5 certify. If you have any questions at all, please let me know. This is the last assignment before break, right? Otherwise, have a great